good case studies from the real world, the real network troubleshooting. And I'm going to ask you to troubleshoot together with me. For the background thing, let me just skip them.
Oh.
Troubleshooting is difficult. That's it. It's not easy. We all want to eat pizza, right? That's the whole idea. So I've been doing troubleshooting for over 10 years. 5-6 years ago, when we do the troubleshooting, we see lots of issues in lower layers. Bad port, bad cable, bad switch. Now, good technology, right? The switch, everything works fine. Cable is working fine. Instead, we see lots of other network issues. What's the issues? It's the user's experience. From network manager point of view, you are saying everything's working fine, but user is experiencing the slow, bad performance. Email is working, file transfer is working, but it's slow. You are the network manager. How do you resolve this issue? So the trending now is the network issue is moving to up layers compared to 5-6 years ago. I'll skip the company introduction. Lots of work. Not important.
I think we should give this guy a round of applause.
Well, for the past 15-20 years, people have been troubleshooting from this. What's this data? It's trace file, right? It's packets, raw packets.
So this
we
is
have
like
been troubleshooting from here. Well, Sniffer is a great technology, but the problem is for the past 15 years, nothing has been changed. Any network channel guy here? Okay, it's a great technology, but it's really hard to find the problem from this data. If you are paid by hours, you can always troubleshoot from here. We try to make life easier. We show you the same idea, same information with much easier presentation. So let's start from troubleshooting. Troubleshooting. This is a case study I did 6 years ago. Actually, the real location is not Seattle and LA. It's Osaka and Tokyo. We did troubleshooting in Tokyo. So this user calls us, say, we have some file transfer issues. Okay. I can copy the text file, TXT file, from one location to the other one. I cannot open the Excel file. I'm sorry, I cannot copy the Excel file.
Is this true even if the text file is really the same size?
Oh, size, yes, good point. So basically, Excel file is bigger, right? Text file is smaller. So I just told him, I don't want to go to your site, but try some big text file, try some small Excel file. And the answer is, even the big text file, everything works fine. Even the small Excel file, still run into error. So you are the network manager. How do you troubleshoot this case? You have several choices. Well, this is the two locations, the WAN and the router in the middle. How do we troubleshoot? You have several choices.
We like number 5.
No.
Hey, I love
Increase the bandwidth. Don't send
Don't
use
do that.
an email, maybe zip it or
I like rebooting the user.
email.
Problem between keyboard and chair.
So that's very interesting, right? Just guessing doesn't resolve this issue. Reboot doesn't resolve any issues. So in order to pinpoint the problem, no questions after I finish this. But go ahead.
Well, you asked how to do it. I would just tar it up and send it that way and untar it.
Oh, okay.
You encode it.
Yeah, then
Send
it's
the-
text.
you send USB.
Text
You
file.
describe you decode the evolution.
Okay.
Yeah.
In order to troubleshoot, to pinpoint the real problem, you must
Next.
see the network first. See the network first. You cannot troubleshoot in the dark. The second one is you must be able to break the code.
I mean, repeatedly.
You must be able to read what the packet is showing you. So that one is a little bit complicated. Before we go to that case study, let's troubleshoot the simple one. I try to show you the concept here. So the network is very simple. I try to make it the concept. Let's focus on the concept. Client, server, network, device in the middle. So let's define the problem first. I try to print out a document. Last page is always missing. Last page is always missing. So how do we troubleshoot? First, you have to be able to see the network. See the network. You cannot troubleshoot in dark. So let's get the data during the network issue. Try to remember this simple picture. Client, server, A and B. A is the client, B is the server side. So every trace file or every flowchart like this is telling you a story. Whether or not you can read this story depends on, well, will determine whether you can resolve it or not. Left side is client, right side is server. So you can see the packet going back and forth, back and forth. It's a little bit hard for you to read this one. So the first packet is a print server send a job, send the packet to the server, print out this one. Acknowledgement, another print job, acknowledgement. All of a sudden we see some yellow. Retry, retry, retry. Why we have so many retries? We capture this data at point B. Point B means the right side network, the server segment. Okay. So from the server point, we see the request coming from the client again and again. What does it mean? Who is the bad guy? Server.
Well, it sounds like the server is not getting some TCP packets to you, so you hit my retry window.
It seems the server is not responding, right? You see the delta time is doubling. This is a very typical TCP retry algorithm. And retry means I send you packet, I'm expecting the acknowledgement, but you are not sending me any acknowledgement. So it looks like the server is not responding. So let's break the code. It seems the server printer is not responding, but we take another look at the packet. We found out there's some message here. Can you read it?
Check some incorrect.
Good.
Line, blah, 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 blah.
Yeah, good point. Check some error. So from server point of view, I'm checking the packet from client. The packet is showing checksum error, which means the packet is broken, right? The packet is broken. Checksum error, just like CRC error, but it's in the TCP layer. It shows checksum error, which means the packet is broken. So if I receive the broken packet, how can I respond, right? So it's not the server at this point. It must be either client or network. Every time you try to troubleshoot network issue, it's either network, client, or server. That includes the application as well. You have different opinion. We can discuss.
No, someone's hacking into your machine and replacing the bits in there.
I doubt it.
That's a client or network server. Must be one of them.
Yeah.
Okay. Well, we check the packet is real, check some error. So at point B, at the server point of view, we see the packet from client has some checksum error. Now we show you a complete picture. This is the left side. This is the right side. So you can see the packet at client side, at server side.
And
You
the thing
see
in the
it's-
middle is the switch?
Well, it's the cloud, really.
Well, but let him,
So
the line in the middle, what's that?
that's the cloud in the middle,
Oh, that's the cloud.
or the switch in the middle.
Right, okay.
So who is the bad guy when you see this picture?
Mhm.
Your network.
It's either the router or the switch.
I don't
Because
agree.
I've seen,
It's the client.
It's the client.
Yes, that's right. Because the switch did not
It's checks number.
destroy the packet.
It
Before the
started off
packet
that way.
entered the switch, it's already broken,
okay, I see.
right?
Where you see the first message up there where it says incorrect?
Yeah, this is
Yeah.
checksum incorrect. That's why we mark it yellow. So, it seems very difficult network issue, but let me show you the whole picture. Everything seems very simple. When you do the troubleshooting, do the divide and conquer. Now we can do it at combine and conquer. Go ahead.
So why can't I see all this using, say, TCP dump on the client?
Because you haven't bought.
No, there's a serious answer behind the question.
Your question again?
Why can't I see all of this using TCP dump or?
Oh, you can see it,
dump
same
app
thing.
On the client.
On the client, you can only see this part.
But
Be-
worse than that, on the client, you often will not capture it at the point at which the checksums are applied.
Right. If you were actually on the end node, you're seeing the packet before it's actually out over the wire.
Right,
I
because
generated it correctly, it got mangled.
there's the stack, right? The OSI stack. Lots of analyzers, they capture before you send it out. So before you put the CRC or
Especially if they're offloading the checksums to offload.
the drive NIC card, yes. So, back to the point. So the concept here is we need to capture from both sides to give you, to pinpoint who is the real problem. So the concept is you must be able to see the network first. Then you do the divide and conquer. That's the concept introduced originally by Sniffer 20 years ago. Now we try to do it combine and conquer. When you see some data like this, tell me what kind of story is this? This trace file is showing you what kind of event. This is like point A, which is client. Maybe it's hard for you to read it.
Client isn't receiving a response.
So who is sending whom what?
So the first one is a SYN ACK,
Yes,
and we're not getting any ACKs back. We're just
right,
sending
right.
SYNs.
So what does that mean?
Problems network or server, it's not the client.
What does that mean?
Means
You
we've
cannot
never
set up
begun
TCP
anything.
session, right?
Right.
What's the reason? Divide and conquer. At this point, we can do some
Is it
kind
plugged in?
divide. So what's the next step you need to do based on this trace file?
See what the other side.
Right, right. Left side is okay. Client is is working very hard, trying to set up a session. But right side, something wrong. Is it server? I don't know. Maybe network, maybe the server, right? So we need to be able to do the divide and conquer at each point. Then we can pinpoint any network issues. Okay. Another example. At point A, I see some conversation like this. SYN ACK reset, SYN ACK reset. What does this mean?
So he's refusing our connection, but he's not doing it. I mean, he's sending a reset, but he's not doing it using ICMP, port unreachable, or host unreachable, or administrative deny, or anything like that.
Right.
It's
So
not telling us why.
why the client cannot set up a TCP connection? From whose fault is this? Client, server, network?
The server's sending the reset.
Yeah. Is it network?
Really?
Is it network or not?
Well, it could be the client because he could be sending some sort of malformed, could be anywhere right now because the other end is getting something
Could be
and he's sending a
anywhere.
reset.
I just want to ask you, client, network, server.
He's trying to convince you need to have multiple test points to chase anything
No,
down
no,
the
no.
network.
From this, no. From
Yes,
this
yes,
point,
yes.
we can know it's not the server for sure. It's not the network for sure, right? Network is perfect. How do I know?
The resets are being.
Because you got to reset.
Right. And network is very fast. How do I know?
Because you got it really quick.
How quick is it?
Too quick.
How quick is it? How quick is too quick?
It's like less than a millisecond.
0.3 millisecond. Good eye. 0.3 millisecond, very fast, very fast. How do I know it's fast or slow? What's the benchmark data? In the LAN, if it's like less than 1 millisecond, you can say it's fast. If it's 2 milliseconds, you can say it's slow. Okay, network is very fast, right? So the client is doing again after the 0.5 seconds, right? And again, it failed, same thing. So why the session is not set up? Because the server is refusing, right? Maybe lots of reasons behind it. Maybe security. The server does not trust the client, as it's mentioned by Jen. Maybe it's not trusted. Maybe the server can only offer service to 10 people. This is 11 requests. Lots of, but that's not the point. The point is we need to read, to understand the code. Then we can go to next step. Okay. Now I have a quiz here to see who can troubleshoot this one. The customer, when we go to customer side, we charge them $5,000 a day. And this one paid us $6,000. Okay, the client cannot connect to the server. The connection was set up, but after a while, the session, communication error happened, and the session is torn down. Okay, let's read this data together. I have to lower my resolution to troubleshoot this projector. Okay, so let's read this data together. This is really fun. It's the same network diagram. Client A, server B, right? Wow, it's really clear. We can see all the sequence data here. So let's go over this trace file. It's telling you a very interesting story. The problem is whether or not you can troubleshoot it. So what's the first packet?
SYN-ACK, length 0.
SYN-ACK, right? Yes, network is fast. It's okay, 1 millisecond. Okay, and I captured this data at client point of view, so you can see the client response is very fast too, right? This is what does this mean?
Round trip time.
That means network round trip delay plus the server's processing time. And this one, what does this mean?
How quickly the client pumps out the next one.
Right. The client is very fast, 0.1. So TCP session setup, perfect. And this packet, what's this packet?
Well, it says push.
Well, it's a real data, right? How do I know it's a real data?
Because it's going to push back.
Yeah, also there's a length, some data.
Yeah, there's some length. The push
Right.
is a weird flag for
pushing the
that.
data, yes. Okay, so what's this packet?
That's length 18.
That's a reply.
Reply
Data.
and some data, right?
Payload.
Oh, we are getting there. So client send 2 data packets after that, number 3, number 4. And server send the response and ACK. Another two packets.
So just a pure act.
Server send ACK. And then all of a sudden, a retry happened. Why?
Server took a long time to send that act too.
Yeah.
Server get a long time to this ACK. This one?
Yeah.
Okay, so why? Why the retry is happening? Who can read this data?
You have to move the window.
$10.
Sequence numbers.
But there's still plenty of window.
Yeah.
Did the machine hang at that point?
No,
No, because it sent back the ACK. Okay.
machine is perfect. You want to try to reboot the PC, right?
No, I just wanted to log into it and find out what was going on.
Well, we log in and PC is working perfect.
The server said, I actually didn't receive your last packet because the ACK number is the same as the sequence number of the previous data packet.
Wow, this is a really sharp guy.
Actually,
I asked I did this practice to lots of class audiences. Yeah.
Transparent
Only
proxy.
few of them can give me a very straightforward answer like this.
Well, I can't
So
read these
explain to everybody why. How did you get there?
When you look in the ACK, the pure ACK. on
You can mention the number.
one,
This is frame number. You can mention
Frame
this.
number 8.
Okay.
It says that the ACK number is 274, I can't read it all, 66 something, ending in 918.
918.
So this is act for which one?
This ACK is saying that the next byte of data I expect is numbered that number, but the previous data packet says that the first byte of data in this packet, the sequence number, is exactly the same number. So
you said this one is this one, right?
yeah, this ACK is saying, hey, I'm
Oh,
still
okay,
expecting
right.
what you thought you sent me.
It's a network.
So this act is acting which one?
It's ACKing the previous segment,
This one?
no, the previous
one?
one
Yeah.
previous to it.
Very good. Very good. Very impressive. So the server only at the frame number 6. So what happened to number 7? We don't know. The client does not know. The client only knows that after 2 seconds, nothing came back. So he starts sending the same packet again and again at the same time, doubling the time interval, 2 seconds, 4 seconds. You want to see the last part? 8 seconds, 16 seconds, 33. So the session is done. Very good. Very
I've got a weird question. Can you go up to frames 1 and 2 again?
sure.
Okay, I know I'm gonna regret asking this question, but why are the sequence numbers identical in those 2 frames?
zero.
Oh, okay,
It's an
it
act.
sent, all right, and then it acted, okay. All right, I got it,
Okay.
One's the sequence, one's the act.
okay.
Well, you should be very proud of your group. You have very sharp guys. Very short time, perfect answers. So from this point of view, what do we know? What's the result of your conquer?
I think we can also speculate that the packets have actually stopped getting to the server because if the server received them and didn't like them, we'd see fast retransmit ACKs.
Okay, so this is captured from point A, which is client. So next step, we go to the server to check what happened to those packets at server side, right? Maybe this packet is dropped, right? Maybe the server is busy. Lots of possibilities, but you cannot guess. You need to go there physically and connect. Again, for the past 20 years, we have been troubleshooting from here. Now, we're troubleshooting from here. But still, you need very high skill, like that gentleman, to troubleshoot these issues. It's still very difficult for enterprise IT group. So, what can we do to make this troubleshooting much easier? Let me show you another picture. This is the same trace file, but I captured it from client and server at the same time. Now, all of us can do the troubleshooting, right? You don't have to be an expert to analyze the sequence and ACK, because now you can see every packet twice, at the client side, at the server side. What does this parameter mean? What does this mean?
That's the single-way trip time, from
Right.
one to the other.
That's the one-way delay, one-way network delay. So lots of data makes sense here. What's this? What does this mean?
How long it was sitting there at the far end.
How fast the server is responding. What's this fact? What's this data? One way back from the other way. And this is, well, now you can see the packet syn egg, right? So let's follow the sequence here. You can see the packet coming, egg. You can see the packet coming, packet come here. Uh-oh. What happened to this packet?
Cloud lost it.
Yes, yes.
PMGU.
And this one is responding to this one because you can check the sequence. I didn't make it big enough, but you can check it later. So this packet is jobbed. That's why the client is doing a retry and retry and retry again. So where's the problem?
Network cloud.
Yeah, the cloud, the switch is dropping the packet.
And it can't be PMTU, by the way, because those packets are way too short. We're nowhere near that.
Good point. Actually, that's a very good point. Let's take a look at. So in this case, so usually my work just stop here. I tell them what's going on. Check the router, why it's dropping the packet. But we can go one step further. We check the packet, see what's the difference between the normal packet and the packet that got dropped, right?
Oh, okay.
So for normal packet, we see the packet a little bit short, right? For the job packet, by the way, this is the first packet got jobbed, right? We don't see it here. Packet length, 500 bytes.
Right.
So it seems it's related to packet length, even though. So we check the router configuration. This network has a VoIP, VoIP. For VoIP, because the packet length is kind of short. So they want to guarantee the voice quality is good. So they put high priority for short frames. So when the network gets busy, they job the big or bigger packet. But that's not the point. The point here is divide and conquer, and combine and conquer. Troubleshooting basic. Divide and conquer. Actually, this has several angles. First, you do the, this is a real network. You do the divide and conquer physically. You can do a capture here, capture there. Every time you do a capture, you know either left side or right side. You do it twice, you can combine them, then you can know network, client, or server. After you do several divide and conquer, you can identify one single box. That's a problem box. Then you go to that particular box. You check you do another divide and conquer from this angle, which is OSI. You need to identify which box, which step, or which layer is the problem layer. Sometimes you need to check the time domain as well, because we are running out of time. You need to understand some basic TCP step, some baseline for LAN, WAN, packet loss. Yeah, this is very important. You need to know which ACK is for which sequence or data packet, because you read the acknowledged number, you know it's acting to that one. This is the virus we captured at customer side. Okay, let's go back to the file transfer error. This is a good one. After we did some warm up, now it's a bit easier for us to troubleshoot this case. We do the capture at point A. We notice there are lots of issues already. So we capture data at point A. We see the data is sending to the server, and we see the retry happens.
So what's NBSS in this case?
Session service.
Right. That's the.
I'm sorry, which one?
NetBIOS session.
Oh, it is NetBIOS.
That's a NetBIOS. Yeah, they just use the Microsoft and JAW to another PC. This is a capture at point B. This is capture at point A. This is B, this is A. So all these yellow packets were jumped. All these packets were jumped. Now we know it's not client, it's not server, it's a network router in the middle, the guy in the middle. So packet, we see the packets at A, but we don't see them at B. The router dropped the packet. Why the router dropped the packet? We check the packet that was dropped. It's very interesting because the key here is Excel is not working fine, text file is working fine. So we check the payload here. For the Excel and Word file, there are lots of code like this. No. 0 hex code. We check the router. That's a very high-end router with lots of intelligent, smart functions. The router, I can't mention the vendor though. The router can check error packet and drop the error packet for you. That's the function, intelligent function. So the problem is the router is too smart. It's thinking lots of payload of 0 are error packet. So it dropped that packet. So after we disable this high-end smart function, everything's working fine.
Smart house being stupid.
Okay, so that's the data troubleshooting case. I do have another good voice troubleshooting case. Let me show you this one. Actually, I have lots of other firewall nice case studies. Maybe
But
next
he'll
time.
tell you after.
Okay, let me show you this voice troubleshooting case. VoIP is a little bit complicated because you have lots of different signaling protocols. It's not just TCP for data. You have H323 SIP, Megaco, MGCP, and Cisco is using skinning. And there's a signaling, and you have RTP, that's for voice. You have different network issues, signaling issues, RTP, voice, bad quality, lots of issues, different layers, different protocols, different vendors. So, well, let's do a troubleshooting together. I hope the pizza is not there yet. Okay, we have two phones, two SIP phones. They can ring each other, no problem. Both ways, they can ring each other. But only one-way conversation. Even though they can ring each other, that's okay.
Is the ring noise
This user can hear this user.
Is the ring noise generated locally?
Yeah, it's by signals. In VoIP, ringing is
It's always generated.
it's signaling information.
So this is the network diagram. We have first phone here. This is the first SIP phone. We have second phone here. And the SIP server is sitting there in the far end. In the voice world, the signaling and the RTP data, the voice data, are traveling to different paths, are talking between different devices, which making the situation more complicated. When they try to ring each other, actually, the two phones are not talking to each other directly.
Right.
Instead, they're talking to SIP server, and SIP server forward message to the other phone. So let's troubleshoot this case together. Let me load the data. So tell me what's going on here.
So you can write them through and ringing, and there should be.
So what's going on here?
Unreachable, somewhere up there.
Well, we're so get used to these kind of pictures, but it's really tough to troubleshoot. Let me show you another view. Oh, the resolution is killing me. This should be a very big, very clear picture. I don't have to adjust this one. A picture is worth 1,000 words, and this one gave you a wonderful picture. Let me show you. And you can learn a lot about VoIP even though you don't know it, because this one is showing you everything. You can see the first phone, you can see the second phone, you can see the first phone initiate the signaling invite. To whom? To the SIP server. The SIP server forward the same message all the way to the second phone. So the second phone respond, trying, ringing, and OK. So the phone is ringing, everything's fine. This is OK for SIP. So everything's working perfect. After the signaling,
So,
But there should be an ACK from the other end with the SDP payload telling
It's 9:30.
the
It's
target
9:30.
phone.
I thought it was
Well,
later.
so pizza and beers.
Okay.
Wow.
Okay, five more minutes. Let's see.
So-
Finish this one quickly.
It looks like the calling phone didn't actually send an ACK through with its SDP payload to let it call.
In this case, the signaling ends with the 200 OK.
Mm-hmm.
This implementation is fine too.
It's
So-
like answering the phone without saying hello,
The phone
right?
is ringing. Now we see the voice coming from the second phone. So we know the first phone cannot hear this guy. That's not because the phone is not working. The phone is sending out the voice. The phone is sending out the voice. But the voice packet entered network, but couldn't cross the network.
Routing issue?
Or
Good catch.
filtering, or
Something in the cloud.
You mentioned
Good
or
catch.
quality of service.
Missing ICMP and
Yeah. So if you take a look at the packet from the other direction, right? This is the RTP packet. You can see the cross network, everything works fine. So we go back to this network diagram. This phone send out packet. Well, this phone can talk all the way to SIP server because he's sending the signaling to 192. But his packet to this guy stopped here. This interface cannot see the packet travel this way.
So maybe there's a routing problem because his own 10 net is
Right.
ambiguous
right.
to try and get through to
Right.
this other one.
Yes. No matter how far, how close, it's a routing issue. It's the subnet, the routing configuration. But that's not important. The point here is we use this nice view instead of raw packets. Instead of this one, you can troubleshoot everything from this view. And it's not just that. Hello? I can't hear you.
Oh my goodness.
So you can listen to it.
Oh, but that's legal now.
Yeah, it's legal. Just
I
ask
can hear
George
you.
Bush.
Well, that's why we need to talk to FBI. And you can play this back in real time. Right now I'm using the trace file. You can play back everything in real time, which means if the user are talking, you can listen to it after
Do you have a
1
view that
second.
allows you to hear it and also see it scrolling up in the upper window to show you which packets are going on as you go?
The packet is here.
Do you have a staircase diagram of sequence number versus time?
This is what you are talking about, probably. This
No,
we show you
no,
the time, sequence, everything.
No, I want the x-axis to be time and the y-axis to be sequence number, and draw all the packets, and you get two staircases.
Okay.
The ACK staircase and the window staircase.
Okay.
And everything appears in the
The
staircase.
point is, you don't want to check 1 million packets. You want to see how many packets is out of sequence, how many packets were dropped, right? And what's the jitter? In that case, you can just go to statistics. You go to check those values. You can see the packet, latency, auto sequence, jitter, mouse value, R value, everything. Okay, one more minute. Let me show you what we can do. Well, we can play back everything. We can play back email, FTP, telnet, everything, you name
Subpoena
it.
that.
And even for the SQL server, we can show you the contents view. You'll be surprised. Okay, so here you can see everything. And you see that? So we can play back and you can check everything from the graph voice or jitter, packet loss, latency. We just talk about email. So let's take a look at email. For every conversation, you can see the flow chart like this with errors specified. And you can see the email as well.
So you have a way to capture on both sides at the same time and then
Actually,
mix it together?
Actually, for this one, you just capture for one side, it's good enough. Because you can
Well, I
see
mean,
the...
when you're troubleshooting and you...
Yeah, when you do troubleshooting, that's a very good point.
So
We
you have to have something capturing at both sides at the same time?
And we can merge the trace file, and we support Sniffer, TCP dump, Ethereum, everything. You can merge them together, and we gave you a nice view.
Oh, okay, so you do a TCP dump on both sides and then,
Yes.
and then play it to this
Right,
end?
because capture is free.
Okay.
Ethereum can do capture. There's no value there. So we can help you to analyze to save you time to troubleshoot. So we can go to pizza now.
Better have your clock synchronized between the two. Actually, I have a question. Is there a way, let's say I did a capture at 2 points and I want to merge them, but I found out that the clocks were different on the two.
Oh,
Is there a way
you
for
don't
me
want to
do
miss
that?
this one. Before we go to pizza, let me show you this one.
So why?
This is a very good question because you use two PCs, right?
Yeah.
PC clock could be 1 year different. So when you merge two trace files, wow, look at this. Auto sync. You just click auto sync. We combine them and figure out the time difference for you.
Cool.
Why don't you just run NTP and synchronize
Oh,
everything?
NTP, it depends on the network delay. Sometimes it may be 100 millisecond error.
So as an ethereal developer, it's my understanding from some of the emails that this product uses quite a bit of Ethereum.
That's right. For decode we use, but for application analysis, that's our engine. So you have the choice. You can select Ethereal or you can select other decode engine. It's totally separate
Talking
now.
about the dissectors.
Yeah, it's separate now. So we do have the
You get that?
eval CD-ROM. You want to try it? You can. It's a full function for 2 weeks. You can play with it. And Brian has a CD with him. And we do have the brochure. We have lots of. You want my